Hello and welcome to the fourth video in the series detailing the UC 2014 ESRI and OSIsoft integration demo. In the previous videos we took a look at the actual functionality, we took a look at the architecture, and we discussed some of the server-side code. In this video we'll be discussing the client-side code. Again, a little disclaimer. OSIsoft and ESRI, we are really committed to releasing products that will help you integrate between both systems. Right now we are not there yet, so that's why we are releasing this demo software really to aid you in your research. So please do not use this in a production environment, but use it as reference material for your research. Again, some important resources. If you want to experience the live demo, please go to vcamp.us/UC demo site. If you want to take a look at the source code we're discussing in this video, go to vcamp.us/UC demo download. Also, we like to encourage you to engage with us in a discussion on what your needs are and what you think of the demo. For that, you can use the link listed under discussion. This will take you to the OSIsoft users community, where we have a dedicated forum to allow for discussion around the ESRI and OSIsoft integration. And also, if you're not a member yet, please go to arcgis.com for ArcGIS Online. This is ESRI's cloud offering that will allow you to create maps, use maps, and add different layers to maps. And that's also what we're using in this demo. So the client-side code is really has two key pieces to it. It is a .NET MVC4 project written in C#. So it also has a server component to it, which serves up the data and allows for easy interaction with the JavaScript and HTML client. So there's the MVC4 project, and there's also a small Windows library added to it, which really has only one task, that is creating images, PNG images of route profiles. And we'll discussing that a little bit later. First of all, let's take a look at the architecture of the client. So if you are familiar with MVC4, you know it's made up of models, controllers, and views. So in this case, we'll start with a controller, and the controller serves up a view, which basically is the HTML, JavaScript, and CSS. In this case, we're distinguishing between who requested the page. So we also support iPad, which the difference really is that it serves up some different CSS. So it has different proportions to it because the iPad screen is a bit smaller. So you want to have different proportions to allow for that better user interaction on an iPad. So the views are really responsible for serving up the HTML, the JavaScript, and the CSS. And from JavaScript, we are able to use ArcGIS API for JavaScript to communicate with ArcGIS Online to get the web map, and to communicate with GeoEvent Server to refresh and get the layers on the map. Also, to get the data out of the PI system, we have a couple of different web API controllers that communicate to the PI system using AF SDK. And this uses REST and JSON over HTTP to communicate with the JavaScript HTML5 client. We also redirect to PI core side, and that's really just a window.open in JavaScript. There's some subtlety to it, and we'll discussing that later on in this video. It's a pretty big project. There are a lot of JavaScript files. There are a lot of controllers and models. These are really the key pieces that you want to focus on. So first of all, there's the controllers folder, which has all the controllers and web API controllers in it that serve up the pages and also serve up the data to the JavaScript client. We're also having different views. So the main view is located in Views Home, and it's called index.cshtml. We're using the Razor engine to render the pages. Also, because we're distinguishing between rendering for the iPad and rendering for basically any other device, there are two master views that reference different CSS files to allow for that better user experience on either an iPad or a desktop. So all the custom JavaScript files are located in scripts/custom, and these are the JavaScript files that make the interaction, make the communication over REST with the web API controllers, and also do the integration with the API for JavaScript. Also, we serve up to different files of CSS depending on whether you're accessing the site through an iPad or through any other client. So there are two CSS files located in the content folder, site.css and site.ipad.css. So if you are looking into improving the user experience or changing things to the layout, these are the files you wanna look at. In terms of models, in terms of serving up the data, two important files. There's one file in the models folder called models.cs that really has the data models, so the data containers that are being serialized to JSON by the MVC4 engine. And there's also a PySystemData.cs file, which basically is the interaction through AF SDK with the PySystem. And one very important key file is the config.js file located in scripts/custom. And this file really configures the client to see what layers are added to the map and what kind of configuration they have. So we'll take a closer look at that file. The config.js file really configures, or really lets you configure how the different layers are presented and what kind of data is attached to those layers. So taking a look at the configuration file, first of all, we specify a web map ID. This is a unique ID of a web map configured in ArcGIS Online that you want to use in your client. Then we have auto refresh attribute, which specifies in seconds the interval between refreshing the different layers on a map. The layers collection has different layers in it, different layer names in it, and this really specifies which of the layers that are configured in a web map you want to use in the client. So only the layers that are specified here will be displayed in the client's toggle buttons, so that will allow you to turn layers on and off. And so the configuration for each layer, so for instance, if we take a look at the Wells layer, you can specify a title attribute. So the different features in that layer have different attributes, and here you basically specify which of those attributes you want to use whenever a title or a description is needed. So in this case, the asset name attribute is configured. Also, you can configure which of the attributes is the actual unique ID of that particular feature, and this is a very important configuration step to get right, because this really is the link between the features that are configured on the web map and the assets that are configured in AF. So in this case, we chose asset ID, which is a unique GUID, the GUID of the AF element, and that is basically our link between the features on the web map and our assets in AF. Also, you can supply a collection of attributes which is called key attributes, which really specify which of the attributes in a F do you want to visualize. For instance, whenever you click an asset on a map. So when you click an asset on a map, a pop-up shows up with the trends, and the key attributes specifies which of those attributes you wanna visualize. There's also a boolean you can configure named refresh. This really configures or tells the client that this is a layer you want to periodically refresh using the auto refresh interval configured above. Also, next to layers, you can specify different events. So these are really referring to event frame templates. So in this case, we have two configured: compressor failure and maintenance vehicle trip. And you can specify a template to visualize or summarize the current status of that particular event frame. And you can use placeholders for attributes in it. So for instance, the compressor failure event has a list template that has HTML in it, and also makes use of those placeholders. The maintenance vehicle trip has a very simple template without placeholders or without HTML, but it does have a boolean called isMovement, and this basically specifies that that particular event frame is tied to a moving asset. So in this case, we're using that for the different vehicles we have on the map, and if you specify isMovement is true for that particular event frame, that will list it as basically as strips of that asset, and that will show up a little bit differently, and also will allow you to use the route playback functionality. So whenever you have moving assets, cars or ships or planes, you want to specify that isMovement boolean to true, so you can use that and render those routes and playback those routes on the map. There are two key pieces I also want to discuss. One is the displays controller. So this is a MVC4 controller located in the controller folder, and this controller is responsible for redirecting to PyCore site. And the reason we're not using direct ad hoc URLs to PyCore site is that on the client we don't know the path to that particular asset, and the ad hoc URL needs a path. In the client, we're using the unique element IDs. So the controller basically translates the unique IDs to paths that the ad hoc URL in PyCore site needs. So to give a quick overview, whenever the client does a window.open of a URL to that particular displays controller, it has parameters in it that have the GUIDs in it for the elements you wanna visualize in PyCore site. So the display controllers basically translates those GUIDs to paths and issues a redirect. So in that case, the browser will redirect to the PyCore site ad hoc URL, and that's a quick way to open ad hoc core site displays using GUID instead of element paths. Also, a little bit of an odd dog is the route profile library. This is a separate library in the solution, and it's a very simple Windows library. It's used by the movement profile controller, and its task is basically to just generate PNG files with a route profile of a non-static asset. So whenever in the client you are asking for event frames of a moving asset, it will have an image tag in it which links to this controller, and that controller will get the movement data out of the Py system and render that PNG and serve that PNG up to the client. So this is really a user interface thing to if you have a listing of those routes, of those event frames, it will allow you to quickly see what kind of movement the event frame has. Additional resources, and it's really depending on how familiar you are with the different subjects, if they are valuable to you. If you are unfamiliar with the ArcGIS API for JavaScript, there's a great website called developers.arcgis.com, which has a lot of great samples in it, and also links to the ArcGIS API for JavaScript samples, and also to the API reference. So if you start developing with the JavaScript API, this is really the place for you to go. And if you have any questions after reading the documentation, there's the forums.arcgis.com. That's really helpful, and there are a lot of people there willing to answer your questions. Any questions or resources related to PyAv SDK, you can go to vcampus.osisoft.com, and there you can get your own personal development Pi system, and also we provide documentation on the different data access methods that the Pi system provides. Also a great resource to start developing with .NET MVC4. If you go to ASP.NET MVC, there's some great resources and samples detailing on what ASP.NET MVC4 is and how you can use it. Also, this client makes extensive use of jQuery and jQuery UI components. So if you have any questions regarding those, go to jQuery.com or jQueryui.com for the UI components. And the trends this sample or this demo is using is the jQplot jQuery plugin. So if you have any questions regarding that, or you want to enhance the trends we're using, please go to jqplot.com, and there are a lot of samples and API references there as well. So thank you very much. I hope this gave a great overview of the client-side code. If you have any questions, please use one of the resources provided in the video, or go to the OSIsoft users community, and we'll be there to answer your questions and help you in your research. Thank you.